What if I told you that the most mysterious traveler in our solar system wasn't a spacecraft, but a rock from another star? This is the story of Oumuamua, the strange interstellar object that passed through our neighborhood in 2017, and how it changed the way we look at the universe forever. Subscribe and like if you're ready to journey into the unknown depths of space. Part 1. The Visitor from the Stars. The night skies have always held secrets, but in 2017, astronomers spotted something that would ignite both scientific curiosity and wild speculation across the world. A telescope in Hawaii detected a faint dot, moving far too quickly and on a trajectory that made no sense. Unlike comets or asteroids that loop around the sun in familiar orbits, this object was flying straight through, a cosmic passerby that entered our solar system from deep interstellar space. They named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. It was the perfect name, poetic, mysterious, and a reminder that this wasn't just another asteroid. It was the first confirmed interstellar object humanity had ever observed. Scientists scrambled to study it before it disappeared forever. What they found made the mystery even greater. Oumuamua didn't look or act like anything we had seen before. It had no tail like a comet, yet it reflected sunlight strangely. Its shape, based on brightness variations, seemed elongated, perhaps cigar-like or even pancake-flat. Some estimates suggested it was hundreds of meters long, tumbling through space. But the most puzzling thing wasn't its shape, it was its motion. As it traveled away from the sun, Oumuamua accelerated slightly, as though something was pushing it. Normally, comets do this when sunlight warms their ice and creates jets of gas that act like tiny rocket engines. But telescopes saw no coma, no tail, no visible outgassing. It was as if an invisible hand was nudging it along. This led to one of the most controversial questions in modern astronomy. Was Oumuamua just a natural rock, or could it be something else? Part 2. A mystery in motion. As Oumuamua sped away from the sun, astronomers had only weeks to gather data before it slipped beyond the reach of even our most powerful telescopes. Each observation made the mystery deeper. Its brightness fluctuated dramatically, suggesting it was tumbling end over end, unlike the steady rotation of most asteroids. That strange light curve hinted at a body with an extreme shape, long and thin like a cosmic needle, or wide and flat like a celestial pancake. But the real enigma was the acceleration. Tiny changes in speed had been measured with precision, and they couldn't be explained by gravity alone. With no visible jets or trail, the usual comet explanation seemed unlikely. The object was moving as though something unseen was propelling it. This strange behavior divided the scientific community. Some argued that we were simply witnessing a never-before-seen kind of natural object, perhaps a fragment of a larger body, chipped away during the violent formation of another star system. Others suggested exotic ideas, a hydrogen iceberg that evaporated invisibly, or a sheet of frozen nitrogen reflecting sunlight in odd ways. Each hypothesis tried to account for the odd shape, the tumbling, and the unexplained boost in speed. And then came the boldest suggestion of all. In 2018, Harvard astronomer Avi Loeb proposed that perhaps, just perhaps, Oumuamua was artificial. His paper raised eyebrows and fueled headlines across the globe. What if this was a fragment of alien technology, a discarded light sail, or a probe built by another civilization passing through our system by chance? The scientific world responded with fierce debate. Many dismissed the idea, urging caution and sticking to natural explanations. After all, extraordinary claims require extraordinary evidence. But the very fact that serious scientists were even entertaining the possibility gave the story of Oumuamua a cultural weight far beyond astronomy journals. News outlets called it the alien asteroid. Sci-fi writers and dreamers saw it as proof that humanity might not be alone. And the public? They were captivated. For a brief moment, the world seemed united in wonder, looking up and asking the same question. What exactly just passed through our cosmic backyard? Yet, while theories flew, the object itself slipped farther and farther away. By early 2018, Oumuamua was too faint to track, leaving behind only questions. We may never see it again, but its fleeting visit had already changed science forever, forcing us to ask new questions about what lies beyond the borders of our star. Part 3. Preparing for the next visitor. Oumuamua slipped quietly out of view, leaving astronomers with a sense of both wonder and frustration. They had just glimpsed the first confirmed interstellar object, and yet it was gone before they could uncover its true nature. For scientists, that fleeting encounter wasn't an ending, it was a beginning. If one messenger from the stars had passed through, surely more would follow. In fact, it didn't take long. In 2019, a second interstellar traveler was detected, Comet Borisov. Unlike Oumuamua, Borisov looked and behaved more like a typical comet, with a bright tail of gas and dust trailing behind. Its appearance confirmed what many had suspected. Interstellar visitors weren't rare miracles, but part of the natural rhythm of our galaxy. We simply hadn't had the tools to spot them before. The discovery of Borisov energized astronomers. If two interstellar objects appeared within just a couple of years, there must be many more slipping through our solar system all the time, unnoticed. With better telescopes, we could catch them earlier and maybe even chase them down. That dream is no longer just science fiction. Space agencies and scientists have begun planning missions to intercept the next interstellar visitor. One such idea is the Comet Interceptor mission by the European Space Agency, scheduled for launch later this decade. It will wait in orbit until a suitable target, perhaps an interstellar comet, is discovered, and then sprint out to meet it, capturing data before it vanishes back into the dark. Other proposals are even bolder. Some scientists have suggested pre-positioning spacecraft in deep space, ready to accelerate toward any unusual object detected entering the solar system. Others dream of building powerful solar sails or nuclear-propelled craft that could match the speed of interstellar travelers, giving us a chance to see them up close for the first time. The stakes are high. Each visitor carries secrets about the environments in which it formed, long ago in star systems far beyond our own. Their chemistry, their shapes, even their strange behaviors could reveal how planets and comets form across the galaxy. And though most scientists remain cautious, there is always the possibility that one of these travelers might not be entirely natural. Oumuamua taught us that the universe can surprise us at any moment. Now astronomers wait with sharpened tools, ready for the next knock on our cosmic door. Part 4. Messages from other worlds. When we look at an interstellar object like Oumuamua or Comet Borisov, we aren't just looking at a rock or a chunk of ice. We are peering into the history of another star system, frozen into a fragment and flung across the galaxy. Each visitor is a time capsule, carrying within it clues about how distant worlds were born. Most of the objects that form in a star system never become planets. Instead, billions of icy and rocky fragments are scattered outward during the turbulent early years of a system's life. Some are ejected entirely, sat adrift between the stars. These lonely wanderers drift for millions, even billions of years before they chance upon another star. And sometimes that star is our sun. Borisov, for example, was rich in carbon and cyanide gas, chemicals also found in comets within our own solar system. That similarity tells us that the chemistry that shaped Earth and the other planets is not unique. The building blocks of life are spread widely through the galaxy. Oumuamua, on the other hand, seemed entirely different. Its lack of a tail, its strange shape, and its puzzling acceleration challenged our understanding of what these fragments could be. Was it a shard of frozen nitrogen chipped off a Pluto-like world around another star? Or perhaps a thin sheet of ice and dust, fragile and unlike anything we've cataloged before? Each theory pushed scientists to think beyond the boundaries of what we had previously imagined. The excitement comes from this. Every interstellar object offers us a chance to test whether our solar system is typical or unusual. Are Earth's conditions and the chemistry that gave rise to life common across the galaxy or rare? If comets from other systems carry the same molecules we see here, then perhaps life's recipe is written everywhere among the stars. And so the study of interstellar wanderers is not just about rocks in space. It is about origins. It is about searching for the universal patterns that may one day answer one of humanity's oldest questions. Are we alone? Each passing visitor is like a whisper from another world, a fleeting chance to hear the stories written in starlight. But whispers fade quickly. To truly learn, we must be ready to listen more carefully next time. Part 5. Eyes on the Sky. For centuries, humanity searched the skies with little more than glass lenses and patience. Today, our tools are far more powerful, yet still, Oumuamua almost escaped our notice. It was discovered by chance in October 2017 by the Pan-STARRS telescope in Hawaii, and within a matter of weeks, it was already fading from view. That brief encounter reminded astronomers of an uncomfortable truth. Our current systems for spotting interstellar visitors are barely adequate. But that is about to change. In the coming years, a new generation of telescopes will transform our ability to scan the heavens. At the forefront is the Vera C. Rubin Observatory in Chile, expected to begin operation soon. Its wide-field camera will be the most powerful survey instrument ever built, capable of imaging the entire visible sky every few nights. With its unprecedented sensitivity, astronomers estimate it could detect dozens, perhaps even hundreds of interstellar objects over its lifetime. Imagine that! Instead of rare surprises once a decade, we may soon find a steady stream of wanderers passing through our solar system. Each discovery will give us more opportunities to study these messengers in detail, to compare them, and to learn how diverse the galaxy's building blocks truly are. Other observatories will play their part too. The James Webb Space Telescope, already peering into the distant universe, can also turn its golden mirrors toward nearer mysteries. With its ability to detect faint chemical signatures, Webb could analyze the gases and surfaces of interstellar objects, helping us decode their composition from millions of kilometers away. And this is just the beginning. The combination of survey telescopes on Earth and space-based observatories orbiting high above our planet will create a network of eyes watching for the next anomaly, the next strange traveler whose path cuts through our neighborhood. With each new discovery, we edge closer to answers. What kinds of materials are common across the galaxy?
Do all star systems produce comets and asteroids like ours, or are there exotic forms we've yet to imagine? Could some fragments even carry clues about life's potential in other corners of the Milky Way? The sky is vast, and the visitors are fleeting. But for the first time in history, we are preparing not just to glimpse them in passing, but to catch them in detail, before they vanish forever.
Part 6. Chasing the Interstellar Visitors. Spotting an interstellar visitor from Earth is thrilling, but for scientists, observation alone is never enough. They want to touch, to sample, to bring back pieces of the unknown. The challenge, however, is speed. By the time we notice an object like Oumuamua, it's already racing away at tens of kilometers per second. To intercept it, we need spacecraft that are fast, flexible, and ready to launch at a moment's notice. One of the most promising projects on the horizon is the Comet Interceptor, a European Space Agency mission scheduled for launch in the late 2020s. The plan is brilliant in its simplicity. Instead of chasing after a visitor once it's discovered, the spacecraft will wait in space, stationed at a gravitational balance point known as L2. When a suitable target, a pristine comet or perhaps even another interstellar traveler, is spotted, Comet Interceptor will dash toward it, deploying smaller probes to study the object up close. But for true interstellar objects, some scientists argue we need even more ambitious concepts. The Project Lyra study, for example, explored ways to catch up with Oumuamua itself, even though it's already far beyond Neptune. Their ideas included using powerful solar sails, thin, reflective sheets that harness the pressure of sunlight, or nuclear propulsion systems capable of generating immense acceleration. Though technically difficult, such designs suggest it may be possible to reach an interstellar object within a human lifetime. Others dream of pre-positioning a fleet of spacecraft in the outer solar system, like sentinels waiting in the dark. With enough readiness, one could be redirected to meet a visitor on short notice. There's even speculation about building long-term cosmic harpoons, spacecraft with the sole purpose of grabbing samples from passing objects before flinging them back toward Earth for study. These missions may sound futuristic, but they're not science fiction. The technology is within reach and the motivation is strong. Every interstellar visitor is a once-in-a-lifetime opportunity, unless, of course, we prepare well enough to make once-in-a-lifetime into once every few years. And why does this matter so much? Because holding a fragment of another star system in our hands would be like opening a book written in an alien language, a book that tells us how worlds are born elsewhere, and perhaps whether the seeds of life are scattered far and wide across the galaxy. The pursuit of these wanderers is more than just science. It is an act of curiosity, of daring, and of connection. To chase them is to acknowledge that our solar system is not isolated, but part of a greater galactic story. Part 7. Seeds of Life Among the Stars. Every time an interstellar object drifts through our solar system, a profound question lingers. Could these wanderers be carrying the very ingredients of life? For billions of years, comets and asteroids have bombarded Earth, delivering water, carbon compounds, and amino acids, the molecular building blocks from which life eventually emerged. If these raw materials exist in abundance here, might they not also be scattered throughout the galaxy, riding on fragments flung from other stars? This idea is not new. In fact, it has a name: panspermia. The theory suggests that life, or at least its chemical precursors, might spread between star systems on drifting cosmic debris. While it remains controversial, panspermia has gained renewed interest in light of discoveries like Oumuamua and Comet Borisov. If fragments from distant systems are constantly crossing paths with ours, then the galaxy could be far more interconnected than we ever imagined. Consider this.
Borisov's chemical makeup, rich in carbon-based molecules, mirrors the kinds of substances we associate with life's origins. It means that the chemistry which shaped Earth is not unique. If interstellar comets are common, then the galaxy may be littered with starter kits for biology, waiting for the right conditions to spark something more. Some scientists even speculate that microscopic organisms shielded deep inside rocky fragments could survive the long journey through interstellar space. The distances are enormous and the radiation harsh, but certain extremophiles on Earth have shown resilience that defies expectation. If life can endure in the most brutal corners of our planet, who is to say it could not hitch a ride across the stars? Even if no living passengers ever make such a journey, the delivery of organic molecules could still change everything. Each interstellar visitor we study might hold chemical fingerprints from another stellar nursery, another world where prebiotic chemistry unfolded in parallel with our own. By studying them, we aren't just learning about rocks, we're exploring the possibilities of cosmic kinship, of shared origins that stretch across the Milky Way. And then there's the most daring thought of all. What if some interstellar objects are not random wanderers, but intentional messengers? A craft, a probe, or even a beacon sent deliberately across the gulf of space. While the majority of scientists lean toward natural explanations, the lingering what if keeps our imagination alive. After all, to wonder about life elsewhere is deeply human, and every anomaly in the sky is an invitation to dream. Part 8. Reflections of Our Future. When we look at interstellar wanderers, we are not only peering into the past of distant star systems, we are also glimpsing what might one day be our own legacy. Just as Oumuamua and Borisov drifted into our solar system, fragments of our world may someday travel outward, carrying whispers of Earth into the galaxy. In fact, it's already happening. Every rocket stage, every probe sent beyond the planets, every satellite that escapes the sun's pull, they all become part of a faint trail of human-made objects stretching into the void. Voyager 1 and Voyager 2, launched in the late 1970s, are already beyond the reach of our sun's influence. Each carries a golden record, etched with music, images, and greetings in many languages, a message in a bottle, cast into the cosmic ocean. From a distant star, billions of years from now, they might appear much like Oumuamua did to us, a mysterious, fast-moving fragment on a strange trajectory. Perhaps another civilization will wonder if these relics are natural or artificial, and debate their origins as we did. This perspective is humbling. Interstellar objects remind us that the galaxy is not a static place. Systems exchange material constantly, through violent collisions, gravitational slingshots, and ejections. Over cosmic timescales, the boundaries between stars blur. Just as Earth may receive fragments from other worlds, so too will pieces of our solar system drift outward, scattering into the Milky Way. And one day, it may not just be fragments. If humanity endures, we may become interstellar travelers ourselves. The same questions we ask of Oumuamua, where it came from, what secrets it carries, might one day be asked of ships bearing our descendants. To send explorers across the stars would be to complete the cycle, no longer waiting for visitors, but becoming them. In this way, studying these wanderers is more than science. It is preparation. It forces us to think about survival, communication, and the stories we want to send into the dark. It asks us to imagine how others might perceive us, and whether we too will one day be a fleeting glimmer in another sky. The interstellar messengers that pass through our solar system are not just relics of other worlds, they are mirrors reflecting our own destiny.
Part 9. Redefining our place in the cosmos. For most of human history, the night sky seemed eternal and unchanging. Stars burned steadily, planets wandered predictably, and Earth appeared to be the fixed stage on which the universe revolved. But the discovery of interstellar visitors shattered that illusion, reminding us that the galaxy is alive with motion, chaos, and exchange. Oumuamua and Borisov showed us that our solar system is not isolated. It is part of a vast network of star systems, all bound together in the Milky Way's spiral arms. Materials do not stay confined to where they are born. They are tossed outward, pulled inward, and shared across unimaginable distances. Our sun, our planets, even the atoms in our bodies may once have been part of other stars, scattered and recycled in an endless galactic cycle. This realization is both humbling and exhilarating. On the one hand, it makes Earth seem small, just one planet orbiting one star, briefly illuminated by the passage of wanderers from beyond. On the other hand, it connects us to something far greater. If the same chemistry is happening across the galaxy, if fragments of countless worlds are mingling here, then Earth is not an isolated experiment. We are part of a cosmic story, one chapter in a book being written across billions of worlds. Interstellar objects remind us that the unknown is never far away. They slip into our skies without warning, forcing us to confront mysteries we didn't know existed. And in doing so, they expand our perspective. No longer can we think of our solar system as a closed box. Instead, it is a crossroad, a place where galactic travelers pass through on their endless journeys. This shift in thinking may be one of the greatest gifts of discoveries like Oumuamua. It forces us to see Earth not as the center of the story, but as part of a living, breathing galaxy. A galaxy where matter, chemistry, and perhaps even life itself are constantly shared and exchanged. In this way, each fleeting visitor is more than a curiosity. It is a reminder that the universe is dynamic, interconnected, and full of possibilities. And it challenges us to ask, what other surprises are waiting in the darkness, just beyond the reach of our telescopes? Part 10. The Endless Mystery. Every ending in science is only a doorway to a new beginning. Oumuamua and Borisov were not just strange visitors, they were messengers, whispering that the universe is far wilder and richer than we ever imagined. They arrived without invitation, lingered for only a short time, and vanished back into the cosmic sea, leaving us with more questions than answers. But perhaps that is their greatest gift, mystery. Humanity thrives on curiosity, and without puzzles, there would be no progress. The strange acceleration of Oumuamua, the pristine ices of Borisov, these are not just oddities, they are sparks that ignite imagination, driving us to look harder, think deeper, and explore further. What if other objects are already on their way, invisible in the darkness? What if the galaxy is filled with countless wanderers carrying not just dust and rock, but the raw ingredients of life? And what if one day we detect something that cannot be explained by physics alone, something crafted, deliberate, artificial? The truth is, we are only at the very beginning of this journey.
The next century will bring telescopes sharper than ever, spacecraft capable of intercepting visitors, and perhaps, one day, the first sample return from beyond our solar system. Each discovery will remind us of one simple fact: the universe is not silent. It speaks through light, motion, and fleeting travelers. We only need to listen. And so the story does not end here. The cosmos is alive, restless, and full of secrets waiting to be uncovered. Each interstellar visitor is not the conclusion of a chapter, but the beginning of another. Because in the vastness of space, the most extraordinary truth may be this: we are not alone in our journey. We are part of an endless story, written among the stars.